So let's take a look at how much bigger is a 12-inch pizza than a 6-inch pizza. So like a naive answer here might be to say, well, 6 inches, duh. But that doesn't quite get at the idea of a pizza. What does it mean to be a 6-inch pizza or a 12-inch pizza? Well, more often than not, pizzas are round. So I'm going to try and draw my best round pizza. Thank you, computer, for your help. And so if this is a 6-inch pizza, then that would mean like the distance across here is my belief that that would be the 6 inches, right? So the 6 inches is a diameter, usually when you talk about a pizza. That's my belief. So then I'm going to draw a 12-inch pizza. So two of the big squares here I'm calling 6 inches. So then let's suppose maybe I'll start here. So there's 6 inches, and that's going to be the center, say, and then another 6 inches that way. So that right there should be 12 inches. So then the top would be up here, and the bottom would be there. So let's see if I can sketch this one. So we come around and down and over and back. Well, not too bad. So this would be a 12-inch pizza. And how much bigger is it? Is it twice as big? How do I figure out that it's twice as big? Now, the deal here is we're not just increasing the distance in one direction, like that way right there. We're also increasing in that direction too, and kind of like all around. So is it twice as big? Question mark. I think what we need to do here is figure out what's the area of these guys to try and get at that. So let's check area. That seems more reasonable, because it's hard to tell exactly how much bigger this 12-inch one is than the 6-inch area-wise. So let's see, for the 6-inch pizza area, and I recommend you write lots of stuff down. Area of a circle is pi r squared. The radius here would be 3. The radius here would be 6. So that would be pi times the radius squared, so 3 inches squared. So pi is around 3. It's a little bigger, but let's just call it 3. 3 squared is 9. 3 times 9 is 27. So it's going to be a little bigger than 27, right? That's my guess. I'm going to use a calculator to find that in a minute. And then let's compare that to the 12-inch pizza area. So that would be pi times the radius, distance from the center of the edge, which is 6 for a 12-inch pizza. So 6 squared is 36, times 3 is what? It's 100 and something, 102-ish maybe, 108, 108-ish. All right, let's get a calculator and find out. So I'm going to jump over to Google and ask Google, what is pi times 3 squared? And Google says it's about 28-ish. So I'm going to go to the nearest whole square inch. So back to my pen. Yep, got it. Blue. Sorry about that. Color switch. So about 28, and I'm going to put it up. A wavy equals means I rounded, right? So that's the approximate symbol, and these are inches by inches, so that's counted in square inches or inches squared. So if I double 28, what would I get? 56? Is this one going to be 56 square inches? Let's go find out. And we'll replace that 3 up here with a 6. And oh my, no, it's a lot bigger, 113 if I round to the nearest whole square inch. Oh, wow, that's quite a difference. It's more than double. So 113 square inches. So how much bigger? Well, what do I multiply by 28 to get 113? Well, that's really a division problem. So let's go back to the calculator and do a division. So we want to take 113 and divide by 28. So how many of these small pizzas fit inside the big one? And it turns out 4 of them. Now it would be exactly 4 if I didn't do any rounding, and so this just came out approximate. And why would it come out to be exactly 4? Good question. Let's look at that in a slightly different way. So next piece of evidence here, let's write in green, 113 divided by 28 is about 4. So that means the 12-inch pizza is 4 times larger, or 4 times the size of the 6-inch pizza. Oops, size of the 6-inch pizza. So that's my claim. I'm just going to double check that that's correct. So I'm going to draw this in a slightly different way. It'd be easier if these pizzas were square instead of round, and there are some places that do rectangular pizzas. I'm not sure I've actually ever seen a square one, but let's suppose you know, let's go even smaller. Let's say this is my pizza right there, okay? And I want to double whatever I'm calling that size. So to double, that means I would have to go out 2 squares that way, and I would have to go out in 2 squares that way. And that's the catch here, that I'm actually, it turns into a 2-dimensional problem. And if you look inside this bigger pizza, you can clearly see there are 1, 2, 3, 4 of these guys right here living inside it. So if you double the dimensions, and in this case, and spell that right, we're doubling dimensions, we're doubling the length, so we're taking 2 times the length, and we're taking 2 times the width. Area of a square is length times width, so this guy right here, we could say this is, is just length times width for its area. This one over here is twice that length times twice that width. You can multiply in any order you want, and this is just a whole bunch of multiplication, so I can rewrite that as 2 times L times W. 2 times 2 is 4, so that gives me 4 times the original length and width. So when we jump from 1 dimension to 2 dimensions, we get a multiple of 4 in the size change, which is kind of cool. Now pizza is actually 3-dimensional, so it probably is a little bigger, but my guess is, let's say this 6-inch pizza is just as thick as the 12-inch pizza. So if the thickness doesn't change, then this is a sufficient analysis of it. That, yeah, the 12-inch pizza, although it is twice as wide, it is 4 times bigger in terms of the mass of the pizza. Okay, kind of exciting, interesting problem, a little hidden dilemma there. Hope this was useful to you. Bye-bye.